We've talked about simple interest, and we've explored compound interest and compared the two different types of interest. So in this lesson, we're really going to focus in on compound interest and the compound interest formula. So first, what is compound interest? So a little bit of a recap. So the interest is calculated based on the original amount, so the principal, and any interest that has accumulated up to that point in time. So this underlined portion here is what really sets it apart from simple interest. In simple interest, we only look at the original amount, but in compound interest, we look at that principal plus all of the interest we've accumulated up to that point in time. Now, this is kind of the default type of interest you'll see in the real world. If you hear people talk about interest or you read things about interest that's being earned or interest that's being paid, it's almost certainly going to be compound interest. So it's used in savings accounts, mortgages, GICs, and there are many, many examples of where this shows up in real life. So let's take a look at the compound interest formula. So A equals P times 1 plus R over N to the power of NT. So we looked at in the last lesson that compound interest is exponential. So it shouldn't be surprising that we have an exponential formula here. And looking at these terms at the bottom, we're already familiar with the future value, the principal, the rate of interest as a decimal, and the time in years from our simple interest formula. But this last one is a bit new, the compounding frequency. So what does that mean? What is the compounding frequency? How does it, using this compound interest formula, we just need a number to plug in here. So this is just theory to show you affect the compound interest formula. So a compounding frequency tells us how often interest is calculated each year. And the more frequently interest is compounded, the more interest actually gets earned. So let's look at two very similar problems. We have $1,000 invested at 10%, compounded annually. That means that the interest is applied one time per year. Conversely, on the right-hand side, we have $1,000 invested at 10%. This is compounded semi-annually. Semi-annually means that this is going to happen 2 times every year. What we're going to do is that 10% of interest is going to be divided by 2, which will give us 5%. And we apply 5% of interest halfway through the year, and another 5% of interest at the end of the year. Now, I'm going to work through an example just to show that compounding something more often gives you more interest. But for the purposes of why this gives us more interest. So looking at the example on the left, we have $1,000. And let's see how much interest we earn after 1 year. So invested at 10% compounded annually. So we're going to earn 10% of interest at the end of the year. So 1,000 times 0.1. That's $100 worth of interest. So at the end of year 1, we have the original money that we started with, which was $1,000, plus the amount of interest that we earned, which was $100. This would give us $1,100. So if we earn 10% interest compounded annually, we would have $1,100 at the end of year 1. Now, I'm not going to calculate it in this example, but if we wanted to figure out how much interest that we were to earn in year 2, it would not be $100, because our interest in year 2 is based on this new figure, which is the original principal plus all of the accumulated interest up to that point in time. So we would actually add $110 interest if we were to calculate year 2. But let's now look at the one on the right-hand side. So it's $1,000 invested at 10% compounded semi-annually. So that means halfway through the year, on year 0.5, we are going to calculate half of 10%, which would be 5%, and that would give us $50 of interest. And then at the end of the year, we would calculate another 5%, but that would be based on this original principal plus the $50 of interest that we earned halfway through the year. So $1,050. So this is the sum of our original investment and the $50 of interest. And we would calculate another 5% of that because that's half of 10%. So this is compounded semi-annually. And this would give us $52.50 in interest. So at the end of year one, we would add the $1,000 that we started with, the $50 that we earned halfway through the year, and the $52.50 that we earned at the end of the year, which would give us $1,102.50. Note when you compare these values that compounding the same amount of interest more often gave us a little more money because the second time we applied that interest, it was onto a figure that already had some interest applied to it. If we were to compound this monthly, we would earn even more money. Now, for the purposes, again, of using the compound interest formula, this side calculation is not needed. We just need to figure out how many times the interest is compounded. And so I've created this table of common compounding frequencies. So if interest is compounded annually, that's 1 time per year. Semi-annually would be 2 times per year. Quarterly, 4 times per year. Monthly is 12 times per year. This bi-monthly one, unfortunately, is a little odd. Sometimes it means 24 because bi-monthly would imply 2 times per month. Sometimes, more rarely, it means 6, which is every 2 months. So that can mean either one of those figures. If it's given to you in a question, it will be specified which one it is. Bi-weekly is once every 2 weeks, and weekly is once per week. So we can figure out the compounding frequency just by calculating how many times does something happen in a year. So if I wanted the daily compounding frequency, I would just have to think how many days are there in a year, and this would be 365. So the more times something is compounded per year, the more interest which is earned or applied. So for example, it may not surprise you to hear that credit card companies apply interest on your credit card every day, because that is the value which applies the most amount of interest out of all of these choices. Okay, so that's a lot of the theory behind the compound interest equation and compounding frequencies. Next up, we're going to look at some examples of using this formula to solve problems which involve compound interest. Our final note on compound interest is a way to estimate how long it will take an investment to double, assuming that the interest is compounded annually. Now, this can be used for interest that is not compounded annually, for semi-annually or monthly or weekly or whatnot, but it is at its most accurate for interest that is compounded annually. So the amount of time that it will take something to double in years is simply equal to 72 over R, where R is the rate of compound interest. But unlike with the compound interest formula, this is as a percentage. So if it is 6%, R would be 6, not 0.06. So it's important that the interest rate for the rule of 72 is as a percentage.